film will have two surfaces. All of you played bubble. Nowadays I think you'll get a bubble gun, no? Soap bubble.
Yes, sir.
That one, please do purchase, or in your home do all these things, rather than asking teacher how it is. You should have the physical idea, purely. This one. So how many surfaces it will have? Two surfaces, no, on either side. It will be exposed to air. What you are seeing in the front and the behind also there'll be air and so film. So two surfaces here. So now, according to the idea, so there'll be molecules present here. So I'll show that molecules by like this. Open, you have to show molecules everywhere. So actually the soap film, this yellow color layer is this one. This yellow color. So what is that molecules I'm drawing? They are here. Able to understand? This will be. So these particular molecules open like this. I have to show everywhere here. I say I have to show everywhere here. It's of, I'm interested in this one. So tell me, like this molecule, what it will do? It will exert force on adjacent layers. So here what do we have? We have a rod, and to this rod I suspended a weight. Okay, let L be the length of this one. So this is soap film. Now, who will balance this weight? Weight, anybody? 1 ton, 1 kg. So it'll be few milligram or microgram it is. Then who will balance this rod? It is a light rod. Who will balance this particular weight suspended? The force due to surface tension. So how do it will act? It will act like this. Not at one point, it always everywhere. Able to understand? So every molecule will exert force on the rod. Every molecule will exert force on the rod. And the force due to surface tension will balance the weight here. So what is the definition? Surface tension equal to how we write? Force per unit length. Then what is the force due to surface tension? Surface tension into length. So then for equilibrium of the rod, for equilibrium of rod, force due to surface tension should balance the weight. Different force due to surface tension into length. Okay, this is what the proof I'm giving. If I add some weight, then what will happen? It will slide down again, more molecules will come and they'll exert force. So like that will happen. So because who is balancing this weight? There should be the other force, because the weight mass, the rod is massless. There should be the liquid only should exert force on this rod AB. And how it will exert? All these molecules will exert force on the rod like this. Able to understand, all of you? You have to think really very, very important. Books, you don't have anything. I'm telling this one. Books, everything is available without diagram. This question is there. This explanation is there directly. The books they write. The weight of the rod AB plus the suspended is balanced by force due to surface tension. They write equation. But how it occurs? This idea. Able to understand now clearly? So now there's a property, no? So suppose molecule which is present here, what it do? It will exert force. This molecule, what it does? It will exert force, you know. This is the side view, somewhere here below. And from here, if you are seeing, you can see you have to show molecules here also. I'm not bothered. Sir, what about molecules? Will they exert force on this also? Yes, they'll exert force here. The molecules will present here, they'll exert force on the frame like this. The molecules which are present here, they'll exert force in this way. The molecules which are present here, they'll exert force on the frame. Able to understand now? So there's a one practical example what you can take it, and you can verify S, who is balancing this weight? The force due to surface tension. I know what weight I suspended. I know the length. And now, is it, shall I write only STL or 2 STL? Anybody answers? There'll be free surface below as well as on top, no? So if you take any notebook, it will have bottom as well as top and bottom surface. Like air will be present here and also behind. No, so therefore this should be how much? 2st. Why 2? Because two surfaces. Able to get this one? So this is one practical example is what we can put it, or else we'll go for one more. So I'll take a wireframe. Yellow color is a soft film. Huh? No. So what I do is like I'll go for a thread. There's a thread. There's a thread I placed it. Hmm? Okay, there's a frame. You can hold it. Huh? You can hold it. I dipped in this one. So what I see that there's a force due to surface tension. The molecules present here will exert a force. Will I agree? And what about the layer? The layer present here will exert a force on the thread, and also the layer present will also exert a force. So therefore, it will be like this. Sir, why you are not showing forces here? Yes, here also will be there. I'm bothered about on the thread and the wire loop. This one. No. So what is this? This is a will categorize all things. So this is what wireframe, and this is the soap film. And what about this? This is the thread. Thread what pen in the form of loop, that one. And what is the state of the thread will be like that only. Now what I do, I'll just touch it. I'll say prick. All of you know pricking, touching. If I just touch it, what pen this soap film will evaporate. Then because of these forces, so what happened to thread? Thread will occupy a circular shape. The thread will take a circular shape. Why circular shape? Because the force will act radially. So finally the thread will take this particular shape, and the soap film will be there only between the thread and the wire frame. In between thread, what happened? There won't be soap film. It will get evaporated. I think all of you, if you touch bubble, what happened to bubble? It will get evaporated, no? It will vanish. The similar thing, the soap film which is there between the thread, it will vanish out. And because of surface tension, what happened to thread? Thread, what happened? Will take a circular shape. Oh. Why it's not coming? So today what happened, you can just digest all these things. So tomorrow what happened, we can start with the numericals. So somehow if a student can understand that why that force due to surface tension, I think that'll be enough. Numericals are, say we have only one formula. I think I wrote formula, no, surface tension force per unit length. That is enough. Now let's come for, so what is this? This is the wire frame. This is the thread. Here is what? So film. Tell me how the force on the surface layer, there'll be exiting force on the wire frame like this. And on the thread, at all points, I'm just showing only at few points. It will be at all points. There's a state of the thread here. I'll show a little bit thick. Tell me like a why thread will take that particular shape, and look at the area between the wire frame and thread. Did it got increased or decreased? Anybody answers? Decrease here, no? So what is the effect of surface tension? It will try to minimize the surface area. If I take this area you take it, no? And you compare this area will be less than this one. So what is the effect of surface? It will minimize the surface area. So you try to see that one. What surface is trying to do? It's trying to minimize its surface area. So what that molecules, they're trying to pull each other. The molecules which are there on surface, what they're trying to come together. Is it okay? They're trying to come together. This is the effect of surface. So due to surface tension, the liquid will try to occupy the minimum surface area. This is the effect of surface tension. Able to understand now? So this for this example. Now this is what practically you can try this one. Huh? So what you should do, you should take some any ring, dip that in a soap liquid. You'll get a membrane. All of you, soap membrane, soap film. Say if you everything on paper not possible, at least this particular chapter. You should know what is that soap film, how it will appear. Thin layer, huh? It's been glowing. No? On that you put a cotton thread. It will there. You just touch it here. This will get evaporated. The cotton thread, which was irregular shape, will take a perfect circular shape. The reason for that, due to force due to surface. So what these forces are trying to do, they're trying to minimize this area. So what is the effect of surface tension? It will minimize the surface area. Due to surface tension, the liquid will always try to occupy the minimum surface area. This what so these are the two examples which you can really try. And what will be present here? Here will be present. Okay, I'm not bothered that one. Okay, these are the two experiments what we can show that one. Or good example, some ants will be walking on the surface of water. No reason for that. The force due to surface tension. The force due to surface tension will balance their weight. Some ants, they'll walk, and some persons will walk. Not possible. Science will not accept that one. You can see some person say that some person is walking on water. Science will not accept. How it is possible? Force due to surface tension can never balance the weight of a body. Okay, getting the idea now? So this is about the basic thing. So now, shall we put one more statement? The effect of surface tension due to surface tension, the liquid will try to occupy, or we will try to possess, will try to possess minimum surface area. So this is due to why the liquid will try to possess minimum surface area. We have to call that as due to surface tension. So once again, here such diagrams are very important. See, like initially what I thought is like there's a general thinking, but applications will come like this. So immediately the moment you get a situation, what you should do, where is a soft film, you should identify. Then here, actually, if you have to show forces by molecules here also. Am I right? I think am I correct? See, molecules don't know that who is present here. So here at this particular thing. So the molecules here will exert a force. So here they'll exert a force. So that's one on thing. Here written why the this particular thread is in equilibrium, net force, how much of force is acting, same thing here. The moment you pick this layer, under action of these forces, what happen? It will expand. Then it become perfect circular one. Okay, fine. So this like this, we are giving a proof for the surface tension. I'll show complete. It will be visible. Any doubts if you have, you can just ask related to this one. Numericals are very easy provided if you understand the diagram. So everywhere a student must have that imagination of surface areas. Okay, I think I just stopped it because other concepts I need more time. We'll stop the class here only.